So this is May 2015 question number 11. A says, I calculate the matrix product BA. So the matrix product AB, A first, 1, 1, 2, 3, because when you're multiplying matrices, the order matters. Times B, 1, 2, 0, 1. Row by column, 1 times 1 is 1, 1 times 0 is 0. Top row right column, 1 times 2 is 2, 1 times 1 is 1. Bottom row left column, 2 times 1 is 2, 3 times 0 is 0. Bottom row right column, 2 times 2 is 4, 3 times 1 is 3. So the matrix product AB would be equal to 1, 2, 2, 7. Sorry, it should be 1, 3. All right, so this should be a 3. Here are 2, and here are 7. All right, show that the matrix product of A and B is not commutative. That is, AB is not equal to BA. So to show that AB is not equal to BA, you have got to find BA. Now, BA um, 1, 2, 0, 1. 1, 1, 2, 3. Top row left column, 1 times 2 is 2, 1 times 1 is 1, 2 times 2 is 4. Top row right column, 1 times 3 is 3, 2 times 3 is 6. Bottom row left column, 0 times 1 is 0, 1 times 2 is 2. Bottom row right column, 0 times 1 is 0, 1 times 3 is 3. So BA would be equal to 5, 7, 2, 3. And of course, by observation, looking at BA and looking at AB, it is clear that AB is not equal to BA. Therefore, show that the matrix product of A and B, therefore the matrix product of A and B is not commutative.
Sir, for the second one, is it 1, 6 or 3, 6?
The second one, 1, 6 or 3, 6. All right, first of all, this should be 9 here. Coming back to your question, it should be a 9 here because 3 plus 6 is 9. But 1, 6 or 3, 6, I'm not getting what you're asking.
3 plus 6, or is it 1 plus 6? 4.
All right, let's find out. Are you talking about top right? 1 times 3 is 3.
Yes.
Or it should be 1 times 3 is 3, and 2 times 3 is 1 times 1. You're right. It's 1 times 1. Very good. So it's 1 times 1 here, and 2 times 3, which is 6. And so back to what I originally had. This was 7. I don't know what's going on with me sometimes. So this should be 7. And in any case, they're still not equal. All right? In any case, they're still not equal. 1 times 1, 2 times 2, that's okay, fine. So since they're not equal, the matrix product AB and BA is not commutative. A inverse is 1 over the determinant of A times adjoint A. Now, the determinant of A is equal to 1 times 3 minus 1 times 2. So this is like 3 minus 2, which is equal to 1. And so A inverse would be equal to 1 over 1. Adjoint, switch around the leading diagonal elements, 3, 1. The lagging diagonal elements stay where they are, but their signs change to -1 and -2. So A inverse, it's simply 3 minus 1 minus 2, 1. That's A inverse. All right? Because when you multiply something by 1, it remains the same. Given that M is the matrix 2x, 2, 9, 3, calculate the values of value or values of x for which the mod of M is 0. So the mod of M would be 2x times 3 minus 2 times 9. So therefore, this is 6x minus 18, that is equal to 0. So 6x would be equal to 18. Divide both sides by 6. And so x would be equal to 3. So in order for the mod of M to be equal to 0, x would be equal to 3. So the B part of the question, it says the position vectors of the points R, S, and T relative to an origin O are, so this is for R, S, and this is for T, R, S, and T. Calculate the value of the mod of OR. First of all, OR is the vector -3, 4. The mod of OR would be the square root of -3 square plus 4 square. I think this is going to be equal to 5. So this is square root of 9 plus 16. And so the mod of OR would be equal to the square root of 25, which is equal to 5 units. So the mod of OR is 5 units. We are to express the vectors in the form the vector RS and ST. Well, RS would be equal to RO plus OS. This is a triangle law of vectors. Start at R, end at S. The next letter must be in the middle. RO is minus OR. So this is minus OR, which is -3, 4. Plus OS, which is 1, 1. This is negative times a negative is a positive 3 plus 1. Minus 4 plus 1. This is 4 minus 3. Then ST is equal to SO plus OT, triangle law of vectors. So SO is minus OS, so it's minus 1, 1, plus OT, which is 5 minus 2. So this becomes -1 plus 5 minus 1 minus 2. So this becomes 4 minus 3. Okay, so the two of them, they're parallel. Actually, they're not just parallel, they are parallel. So ROST, I think. Well, let's find out. So so we found RS and ST. Let's see what else we're asked. Using the results of combining the vectors in R, B, I on page 33, justify that RS is parallel to ST and that RS and T is a straight line. So first of all, RS is equal to ST and they are both equal to 4 minus 3. So therefore, RS and ST are parallel because they are scalar multiples of the same base vector. And R, S, and T is a straight line collinear because RS and ST are parallel and S is a common point. So if you have two vectors which are parallel and they share a common point, those two vectors essentially form a straight line. So RS and T is a straight line because RS and ST are parallel and they share a common point, and the common point is S. All right, that's the end of the question.